The following video will introduce you to the concept of design of experiments or DOE and will demonstrate how to use gradient-based optimization with DOE approximations in VisualDOC. What is DOE? The particular arrangement of points in the design space is called as design of experiments or DOE. The DOE component in VisualDOC can generate a sample in design space, can evaluate responses at sample points, and can fit an approximate surface to the responses. Now let's start with an example. I will be solving a stepped rectangular cantilever beam problem. A cantilever beam with 3 equal length segments is used. The total length of the beam is 500 centimeters. The beam is loaded with vertical force of 50,000 Newton at the tip. The design variables are width and height of each segment. Responses includes volume of the beam, displacement at the tip, and the maximum stress in each segment of the beam. Here, objective is to minimize the volume of the beam. It is subjected to constraint that deflection at the tip of the beam should be less than or equal to 2 centimeters. For maximum stress in each segment, lower bound is minus 20,000 and the upper bound is 20,000 Newton per centimeter square. Constraints on design variables: for width of each segment, lower bound is 1 centimeter and upper bound is 5 centimeters. For height of each segment, lower bound is 40 centimeters and upper bound is 60 centimeters. This is a simple example for demonstration. VisualDOC has a capability to solve extremely complex optimization problems. Now let's open VisualDOC. Click on the File button on the main menu bar and select New Project. Select the folder where you want to save the project. Now the next step is to create workflow. From Component Palette, insert Optimization Component. Now select Design of Experiments component and place it inside Optimization component to make it as subflow for optimization. Now add a executable wrapper component inside Design of Experiments component. Executable wrapper component is an amalgamation of executable and file input-output components. Now add a stop block. Now select Flowchart Components in Model Tree panel and click on Auto Connect All Models icon. This would connect all the components based on their order in the model tree. Now click on Automatically Rearrange All Models icon and select Yes. Next, we will set up the executable wrapper component. Go to Component Editor tab. Select Executable Wrapper component from Model Tree panel. Now enter the design variables and responses in the middle panel. Select Output from drop-down list in front of responses V, D, S1, S2, and S3 in Input-Output column. Initial value for variables W1, W2, and W3 is 2.5. For variables H1, H2, and H3, initial value is 50. Now in Run Location section, make sure that Analysis Runs Locally radio button is selected. For Analysis Working Directory, select Use the Model Directory as Directory Part Type. For Local Analysis Program definition, make sure that Relative to Analysis Working Directory option is selected as a file part type, as I have saved the analysis input-output files in the same location as that of VisualDOC model. Now click on the file icon and select your analysis file. For input file definition and output file definition, make sure that Relative to Analysis Working Directory option is selected for file part type. Now click on File icon and select your input file. For output file definition, click on File icon and select your output file. In order to ensure the interaction between VisualDOC and analysis program, push the test button. After successful execution, you will get a message in Standard Messages tab: the executable program runs successfully. Now next step is to create data transfer for DOE component. Go to Data Linker tab. Select DOE component in Model Tree panel. Select DOE component in middle panel. Make sure that Auto Link checkbox is selected. Now click on Automatically Add Data to selected model icon. This will create data needed for the design of experiments component and add corresponding links for the data transfer. Now the next step is to set up the design of experiments component. Go to Component Editor tab. Select DOE component in Model Tree panel. For variables W1, W2 and W3, lower bound is 1 and upper bound is 5. For variables H1, H2 and H3, lower bound is 40 and upper bound is 60. In the panel on the right, select Create DOE with Approximations for DOE action. This will create a set of points and perform an analysis for each point to generate the response data. For DOE model, select Forward Stepwise Regression. Here, minimum number of points for selected model are 7. These are the minimum number of points required to construct the approximation model. For designs, select Composite. Select 2 raised to 6 minus 1 fractional factorial from the Options drop-down list box. The total number of design points generated will be 45. The reason for selecting fractional factorial, it will select the subset of the experimental runs of the full factorial design, which will help to expose the most important features of the problems at a lower computational cost. Now click on the checkbox corresponding to Show Advanced option. From Data Reuse, select Reuse Approximation from first invocation when run as a subflow. Thus, once approximation model is constructed in DOE module, it can be reused in subsequent optimization process whenever a new design point is passed in and response is required. Now the next step is to create data transfer needed for the optimization component. Go to Data Linker tab. Select Optimization in Model Tree panel. Select Optimization in middle panel. Make sure that Auto Link checkbox is selected. Now click on Automatically Add Data to selected model icon. This will add the corresponding links for the data transfer. Now, next step is to set up the optimization component. Go to Component Editor tab. Select Optimization in Model Tree panel. For design variables, enter the lower and upper bounds. For data V, select the checkbox in Objective column. Deselect the checkbox under Constraint column. Make sure that Minimize option is selected under Goal column. For data D, upper bound is 2. For data S1, S2 and S3, lower bound is minus 20,000 and upper bound is plus 20,000. I will be using modified method of feasible direction, which is default gradient based optimization method in VisualDOC. Now I will create two simulation monitors to monitor the best objective and the worst constraint violation. Go to Simulation Monitors tab. Add two optimization history monitors. Now click on the Expand Hierarchy icon below the Flowchart Components panel as well as the List of Monitors panel. Now drag the best objective under Simulation Parameters and drop it on the X1 axis of the first monitor. Similarly, drag the worst constraint under Simulation Parameters and drop it on the X1 axis of the second monitor. To activate the defined monitors, click on Enable All Monitors icon. Now click on Validate icon. Our complete model is valid. Now click on Run icon. To view the defined monitors, click on View Monitors tab. For both optimization history monitors, x-axis represents number of iterations. First optimization history monitor displays best objective value for each iteration. Second optimization history monitor displays worst constraint value for each iteration. The total number of iterations are 8. It can be seen from the graph that for iteration 0 there is a constraint violation. To check which constraint is violated, go to Post-Processing tab. Select Optimization in Model Tree panel. Now click on Generate Summary Report icon. Scroll down to iteration 0. Here you can see that the stress in segment 1 is 27,594, which exceeds the upper bound of 20,000. For first iteration, volume is 66,412 cubic centimeters. After 8 iterations, it has been reduced to 46,965 cubic centimeters. To view the optimum results, go to Component Editor tab. Select Optimization from Model Tree panel. The table displayed in the middle panel has the optimum values in the optimum column. The total reduction in volume is approximately 30%. To check the approximation models, go to Post-Processing tab. Select DOE Component from Model Tree panel. Now click on Launch 3D Approximation Viewer icon. Now select the first invocation as we are reusing the approximation from the first invocation. Select the input variables by clicking on the checkbox. You can change the values of the input variables by moving the slider. The corresponding change in the output can be observed. You can also plot all the design points by clicking on Show Design Points icon. In the same plot, you can plot approximation models for any number of responses. You can check approximated equations for all the responses in Approximated Equations section. This completes the demo. I hope it has helped you to get familiar with design of experiments in VisualDOC. If you would like to learn more, I invite you to check other videos about VisualDOC. For additional information, please visit our website at www.vrand.com or email us at visualdoc.support@vrand.com. Thanks for watching.